Administering DNS. No discussion of DNS would be appropriate without an in-depth look at administering your DNS server. So we're going to start by looking at the properties of our DNS server. So we'll click on Start, Administrative Tools, and then we'll launch the DNS MMC. Now to get to the properties of our DNS server, we'll right-click on our DNS server and we'll select Properties. Now up here you can see we have 7 tabs and we'll go through them all one by one. Now our default tab, the Interfaces tab, is where we can set which network interfaces we want to have DNS listen for DNS queries. Now the default here is to listen on all IP addresses. Now in our case we only have the one single network card, but if you are running multiple network cards in your server you can leave the default and it will listen on all network cards, or you can select a specific network card by choosing only the following IP addresses and then punching in your IP addresses here, clicking on Add, and then they'll be brought down into this window below. On the Forwarders tab, this is where we can set additional DNS servers to which this DNS server will forward its queries that it cannot resolve locally. Now I'm not going to go any further into this topic as we have a complete video on forwarders later in this DNS series. Now on the Advanced tab, this is where we can set options that affect the advanced configuration of our DNS server. Now at the top here we can see the version of our DNS server. Now underneath here in our server options window we've got a few very important options. Now in most cases you're going to leave the defaults as they are, but we'll go through them each now and then you can make up your own mind. Now our first option here is to disable recursion, which as it says also disables forwarding. Now by default recursion is enabled for the DNS server service. If recursion is disabled, the DNS server service will always use the referral or iterative method regardless of the client request. Now Windows 2003 DNS servers can, and by default do, use recursion to query other DNS servers on behalf of the requesting client by contacting all of the DNS servers it can in turn to find the answer. Now in contrast, the root servers use an iterative response, which basically says, hey, go and ask that server over there for the answer because I'm not going to do it for you. But recursive lookups continue until the server receives an authoritative answer for the queried name. Then this DNS server will forward this answer in a response to the original query from the client that requested it. Now generally you would only disable recursion if you only want the DNS server to only manage internal names, or the server perhaps is unable to resolve any external names. Now in this case our clients would be expected to try another DNS server to resolve those names. The bind secondaries option, which is enabled by default, adds support for the fast transfer format during zone transfers. Now if you happen to be using Windows only DNS servers, I'd leave this box checked to maximize your DNS zone performance. Now the only reason you'd want to uncheck this box is if you're also transferring zones to bind servers running version 4.9.4 or earlier, which do not support the fast zone transfer format. Now fail on load if bad zone data determines whether we force our DNS server to parse zone files strictly. Now by default the DNS server service will log data errors and just ignore any errors that are contained in our zone file and continue to load it anyway. Now if we check this box, it will prevent the DNS server from loading a zone that contains an error. Now the default is disabled and I recommend that we leave it that way. Now round robin allows us to set up multiple host records for a given host name and have the DNS server dish out those IP addresses in order. So let's say that I have 3 servers that I want to load balance as a single web server. Just by leaving the default setting of round robin enabled and creating a few host records, we can have a poor man's load balance server. So to illustrate how round robin works, what I'm going to do is I'm going to click cancel for the moment. I'm going to go into my forward lookup zone and then my testdomain.com zone, and I'm going to right click and select a new host record. Now I'm going to give my host record a name of www and I'm going to give it an IP address of 192.168.0.100 and I'll click on add host. Now I'm going to do the same thing again, www for the host name, and I'm going to give this one an IP address of 101 and I'll click on add host. And now I'm going to do it one more time, www, and I'm going to give this one an IP address of 102 and click on add host. Click OK, and now we're done. So to see round robin in action on our DNS server, we're going to go and click on start, command prompt, and we'll type in nslookup www.testdomain.com and we'll hit enter. Okay, now we can see the first IP address that came back was 192.168.0.100, followed by 101, followed by 102. So let's enter that command in again, and we can see that 102 came back as the first response, followed by 100, followed by 101. So we'll try it a third time, and we can see now that 101 came back first, followed by 102, followed by 100. So if we were to do this a fourth time, what IP do you think would actually come back? Well, I'm tipping it's actually going to be .100, but we'll see if I'm right. And yes, I am. Now, round robin will repeat this sequential dishing out of IP addresses on a continual basis, which certainly can alleviate a busy server by distributing the load to our different servers. The main downfall of using round robin, though, is if one of these servers happens to die, DNS is not made aware of it and will continue to dish out the dead IP address. So effectively this means that in a situation like we've got here with these 3 IP addresses, that every third hit on our website would fail. Okay, so we'll go back into the properties of our server and back to our advanced tab. Now the next option we had here was to enable net mask ordering, and this determines whether DNS will use a local subnet priority. Now in the situation where you have a multi-home computer, that is a computer with multiple network cards, the one which is determined to be closest to the DNS server will have priority. So for argument's sake, assume we've got 2 network cards in a computer. One has an IP address of 192.168.0.100 and the other one has an IP address of, say, 10.10.10.100. Now because our DNS server here is on the 192.168 network, the 192.168.0.100 network interface would be given local priority. Now again, we can demonstrate netmask ordering. I'll click cancel here, and what I'm going to do is I'm just going to right click on one of my host records here and delete it. Now I'm going to choose one of the other ones, and I'm just going to go and change its associated IP address to 10.10.10.100 for argument's sake, and we'll click on OK. Okay, now we'll go and open up a command prompt again, and we'll type in nslookup www.testdomain.com and we'll hit enter. And we can see that the first IP address that came back was our 192.168.0.100, and of course the 10.10.10.100 came second. So we'll enter in that command again, and again our 192 came first. So if we did this a third time, you'll note that it's always going to be the 192.168 network interface. And that's because our DNS server is on this subnet and it prioritizes the local host as being the first host returned in a query. So there you can see netmask ordering in action. Okay, we'll go back again into our properties of our DNS server and click on the Advanced tab. And our final option here was to secure our cache against pollution. Now leaving this option to its default setting of enabled will let our DNS server attempt to clean up responses to avoid cache pollution. Now this setting eliminates adding unrelated resource records that are included in a referral answer to the DNS cache. Now if our DNS server discovers that a referred name is insecure or it's potentially bogus, it will discard it. Now our DNS server will check the response that's been given in a referral to see if it came from the same DNS domain name which the original request was for. So for example, if our DNS server sent out a request for a web server at nec.com and the response comes back as something outside that domain structure, such as the web server from compact.com, then the DNS server won't cache the response. Now DNS by default will use the multi-byte Unicode 8-bit translation encoding scheme, although you certainly can change this to an ANSI scheme if you feel you have the need. Now by default, Active Directory integrated DNS servers use information stored in Active Directory and in the registry to initialize and then load any zone data for use at the server. But if you wish, you can certainly change this so the DNS server boots from simply a file or from the registry. Now non-Active Directory DNS servers will initialize from the registry information. Now if you do use the file must be a text file named boot, and it must be located on your DNS server in your system root system32/DNS folder. Now we can also enable the cleanup of old records. Now if we enable this setting, the default will be set to 7 days, but you can certainly change this setting if you wish. And with regards to all of the settings that we see here on the Advanced tab, if we totally muck everything up on this tab and we've forgotten what the original settings were, we can click Reset to Default and everything will be back the way it was when we first installed our DNS server. Now on our Root Hints tab, this is where we can set the IP addresses of the root DNS servers. Now this information has been populated for us automatically when we first installed our DNS server, and it's not recommended that you change these. But if for some reason your copy happens to be modified or corrupted, you can certainly edit these if you wish. So to change one, we just simply highlight an entry and we'll click on Edit, and then we can change these records if we like. Now our Security tab provides us with the standard Windows access control list where we can assign permissions to users or groups to determine if they're able to create, modify or delete any of our objects on our DNS server. Now by default, only members of the administrators, domain admins, enterprise admins and the DS admin groups can make changes to our DNS server. Now on our Monitoring tab, we can perform some basic tests against our DNS server. We can choose from a simple query or a recursive query, or we can perform both. So to run a test, we'd simply click on Test Now. And then the results will be displayed in the test results window at the bottom. Now we can also schedule automatic testing at certain intervals if we like. Now this does default to 1 minute, and I certainly wouldn't recommend that you test your DNS server every 1 minute, but you can certainly change this if you like. I'd set it at something like an hour or a couple of hours, but that's entirely up to you. On the Event Logging tab, this is where we can tell our DNS server to write records to the event log when errors or warnings occur. Now the default is to log all events, but you can choose to have no events, errors only, or errors and warnings. Now I recommend that you leave the default setting to all errors, because when dealing with troubleshooting an important service like DNS, I prefer to have as much information on hand to assist me, so I'd leave this setting at all events. Now our Debug Logging tab is where we can tell our DNS server to log to a text file the packets that are sent to and from our DNS server. Now take note though, debug logging on your DNS server will slow down its performance, so only use it for troubleshooting and turn it off during normal use. Now by default it is disabled, but we can enable it by checking the log packets for debugging box. Okay, so with debug logging enabled, we can then log packets traveling outbound from our DNS server or coming inbound to our DNS server. We can also provide logging based on whether the packet is a UDP packet or a TCP packet. Now for the most part, DNS uses UDP, so you'd probably enable this one if specifying protocols. TCP is used for zone transfers and very large responses, so depending on what you're trying to troubleshoot, use that as a guideline. Now we can also filter on packet contents, such as DNS queries or transfers, dynamic updates, or notifications to other DNS servers that our zone data has changed. Now similar to our packet direction, we can also log packet types, whether it's a request for something or whether it's a response to a request. Now we can also log the details and filter out our packets by specific IP addresses if it happens to be a specific host that we're trying to debug. Now here, under the log file box, you can specify a path and a file name for the debug log file. Now if you just enter in a file name here and you don't enter a path to the file will be saved in the system32/DNS directory. Now finally at the bottom, we can also set a maximum size that we want to allow our log file to grow. Now if this maximum size is reached, then the file will be overwritten, starting with the oldest records first. Okay, so that's the properties of our DNS server. So what we'll do now is we'll click on Cancel, and we'll go and right click on our DNS server, and we'll take a look at the right click context menu. Now our first option is to configure a DNS server, and this simply restarts the Configure a DNS Server wizard that we used when we first installed a DNS server early in this video series. Now our next option is to create default application directory partitions. Now an application directory partition is a directory partition that's replicated only to specific domain controllers. Now a domain controller that participates in the replication of a particular application directory partition only hosts a replica of that partition. And only domain controllers running Windows Server 2003 can host a replica of an application directory partition. Now one of the benefits of application directory partitions is that for redundancy, availability or fault tolerance, the data in it can be replicated to different domain controllers in a forest. This data can be replicated to a specific domain controller or any set of domain controllers anywhere in your forest. and that differs from a domain directory partition in which data is replicated to all domain controllers in a domain. So storing application data in an application directory partition instead of in a domain directory partition may reduce replication traffic because the application data is only replicated to specific domain controllers. If we choose this option, we're asked if we'd like to create a single partition that stores DNS zone data, which will then be replicated to all of our other DNS servers in this domain. Now at this point, if we select yes, we're going to get an error, and that's because this partition already exists. So to verify what partitions we already have installed, we'll go and open up a command prompt, and then we'll type in ntdsutil and we'll hit enter. Now at any time with the ntdsutil command, you can type in help or simply enter in a question mark and hit enter, and you'll get a list of the available options. Now as directory partitions are a domain controller function, we need to manage our domain, so we need to use this option up here of domain management. So we'll simply type in domain management and we'll hit enter, and we can see that our prompt down here changes to represent the fact that we're now in domain management mode. Now by the way, at this point we're actually not connected to a server, so querying our domain controller at this point won't help. Now we can prove that by typing in list, and you'll see that we get an error. And again, if we need to take a look at what available options we have, we can certainly type in a question mark, hit enter, and you'll see the options that we actually have up here. Okay, so the next option we need to do is type in connections because we need to connect to our server. And now we need to specify the server that we want to connect to. So we'll type in connect to server, followed by the name of the server that we wish to connect to. Now in our case, this is server 01, so we'll hit enter. And you can see now that we're connected to server 01 using the credentials of the locally logged on user, which in our case is the administrator account. Okay, now that we're connected to our server 01, we need to type in quit to get back into the domain management section. So now to find out what partitions we have, we can simply type in list and hit enter, and we get a list of the directory partitions we have. Now directory partitions is rather out of scope for our discussion on DNS, but if you go and view our videos on Active Directory sites and replication, we discuss this topic in more detail. Okay, so we'll go back to our server, we'll right click, and our next option here is to create a new zone. And this just starts up our new zone wizard, allowing us to create forward or reverse lookup zone. Now this is essentially the same as us right clicking on either of our forward or reverse lookup zones and then creating a new zone. Now we can also set the scavenging or aging properties for all DNS records, and we saw how to do this earlier. Next we can choose to scavenge all of the records in our DNS server immediately by selecting this option. Then updating our server data files causes our server to write changes that are in memory out to disk and store them in the zone file. Now whereas in a normal operation these changes are held in memory and they're only written out to disk at predefined update intervals or when the DNS server is being shut down. Now updating server data files is only relevant for a standard primary zone. If you are using Active Directory integrated zones, then this setting does nothing. And then what you'd have to do is we'll drop out to a command prompt and we'd type in DNS command followed by our server name, in our case server 01, with the /zone update from DS followed by the name of your zone. And that'd do exactly the same thing for an Active Directory integrated zone. Now our other option here was to clear our DNS cache, which does what it implies, and it clears the DNS server cache. Now we can also perform the same task from the command line by entering in the DNS command followed by our server name with a /clear cache as one word. Now our final option on our menu here was to launch NSLookup, and that will just fire up a command prompt already in NSLookup mode, and that's kind of useful if we're really too lazy to type it in manually. Okay, so that's the properties of our DNS server. Now let's go and take a look at the properties of our zone files. So we'll right click on our forward lookup zone of testdomain.com and select properties. Now on our default tab, which is a general tab, we can see the status of our DNS server, which is running. Now we can pause it over here if we wish. Now the type of server we're currently running is an Active Directory primary integrated zone. Now if we did want to happen to change this to a secondary or a stub zone, then we can click on change and then we can change to one of the other available types. We can also see that this zone is going to be replicated to all DNS servers in our Active Directory domain, which is testdomain.com. But of course we can change it if we wish. We could change it to replicate with all DNS servers in our forest, or just domain controllers in our testdomain.com domain. Now we can also see the dynamic update settings is set to secure only because we are running in an Active Directory integrated zone. But if we liked, we could also change it back to none or to non-secure and secure, although I certainly wouldn't recommend that. If you have the ability to run Active Directory integrated zones, then you should certainly use secure only. And finally down here we have the aging button. Now if we click on this, we can set how long our DNS clients must wait before attempting to refresh their host records with our DNS server. Now Windows hosts will attempt to register themselves with a DNS server every 24 hours or when they reboot. So setting this option here prevents them from doing so, and of course it will save a lot of network traffic, especially in a large environment. So by choosing this box combined with our default no refresh interval of 7 days, this means that our Windows clients will not be able to refresh their DNS host entry for a total of 7 days. And of course down here, after this amount of time expires, then the client will refresh itself in DNS. So after 7 days, host will re-register in DNS. Now if records aren't refreshed, checking this box at the top will scavenge or remove stale DNS records from our DNS server. Now checking this option is a good idea because DNS will remove host records that appear to be no longer in use, or perhaps maybe a user's on holiday or something and hasn't logged in for a while. So this option is recommended from keeping your DNS server from growing unnecessarily in size. So we'll click on OK and we'll move on to our Wins tab. Now here we can select to use a Wins forward lookup, and if DNS cannot resolve a hostname because it doesn't have a host record in the authoritative zone, it will query the Wins server. So let's say we're trying to resolve a computer named bobspc.testdomain.com. If DNS cannot contact bobspc.testdomain.com, it will strip off the testdomain.com portion of the name and then send the Wins server a NetBIOS name request using the host. In this case, it would just be bobspc. And if bobspc is registered in Wins, the Wins server will return the record to DNS. And then DNS will create an A record or a host record in its zone and then forward the IP address of bobspc back to the client that requested it. Now if you do have non-Windows 2000 or 2003 DNS servers such as bind servers, you might want to check the next box, do not replicate this record. Now this is because DNS servers other than Windows 2000 or 2003 don't handle Wins records very well, and you might have zone transfer problems. Now the Advanced button just allows us to cache host names that it resolves, and this will keep these records by default for 15 minutes. Now in the lookup timeout field, this just says that if it doesn't get a response from the first Wins server in 2 seconds, it'll move on to the next one in the list, and so on and so forth. And if it exhausts all of the Wins servers, then you'll just receive an error message. Now on our Zone Transfers tab, this is where we can configure, for example, our secondary servers to receive a copy of this zone. Now by default we will allow zone transfers, but only to servers that are listed on the Name Servers tab. Now this is a good setting as we've already defined the name servers on our Name Servers tab. But if you do want to add some specific servers, you can click only to the following servers and then type in the IP address and click Add. Now we can also allow zone transfers to any server, but that's kind of a security risk, so I would try and keep my choice isolated to one of these 2 settings here. Now normally a secondary DNS server will contact the primary DNS server every 15 minutes to see if there's been any updates to the zone. Now if we click on the Notify button, we can set our DNS server to contact the secondaries and tell them when an update has occurred. Now this will occur outside of the normal 15-minute update interval and it won't affect it in any way. Now the default is to automatically notify our secondary servers, but only servers which we've specified here in this window below. But of course you can certainly change that to all of our servers that are listed on our Name Servers tab. Okay, our next tab here is the Security tab, and this just provides us with a standard Windows access control list where we can assign permissions to users or groups to determine if they're able to create, modify or delete any of our objects in our zone. Now on our name servers tab, we can specify name servers that are authoritative for our zone. Now we can see here that server01.testdomain.com server is listed as our authoritative name server. Now if we wanted to add an additional server, we can simply come down here and click on add, and then enter in the fully qualified domain name of our server and its IP address, or alternatively we could just enter in our server name and then click resolve. Now if you do have servers in here that you want to remove, you can simply highlight it and click remove. Alternatively, we can click on edit, and then we can edit any of these details here. Now finally we have the Start of Authority tab, and here we set the information about the primary DNS server for our domain. Now the first field we have here is the serial number, and this is where secondary DNS servers will compare their serial number against our primary server's serial number, and if this number here happens to be higher than theirs, then a zone transfer will be performed so that the secondary server can have a current copy of our zone. Now this serial number will increment automatically as changes are made to this zone. But if we want to ensure that a zone transfer takes place, we can increment it manually if we wish by clicking on the increment button. And that'll just ensure that our serial number is higher than that of the secondaries so that a zone transfer will take place. Now next we see the name of our primary DNS server, which as expected is our Server01 machine. Now as you can see, our server name does have this trailing dot after it. Now that indicates the full path back to the root. Now in most situations we don't ever see or have to enter this trailing dot when we ping anything or open a web page or anything like that, but DNS does use it behind the scenes. Now next we see the responsible person, and this is actually an email address with the @ symbol replaced by a dot. And that's just so that this email address is valid as far as DNS is concerned. Now the default is set to hostmaster, but we can change that if we wish, and again to be complete we do see the trailing dot at the end. Now our refresh interval here defines how long our secondary servers will check back with this DNS server to see if there's been any changes. Now any secondary servers will check the serial number as we mentioned before, and if there have been changes then it will initiate a zone transfer and pull those records to the secondary. Now if there are any problems performing a zone transfer, then it will retry after the interval it's specified here, which defaults to 10 minutes. Now if it is unable to contact this server for a full day, then the secondary will expire its copy of the zone and it will be no longer used. Now if the secondary then contacts this primary successfully, it will reactivate its zone and then perform any necessary zone transfers. Now the minimum time to live, or TTL, is set to 1 hour, and this means that when a client successfully resolves a host name using this DNS server, it will cache the name and IP address for an hour before it expires. And also down here we can see the time to live for our Start of Authority record itself is going to be kept for 1 hour as well. Okay, that's our forward lookup zone. So let's go and expand, and we'll select our reverse lookup zone, and we'll right click on that and we'll select properties. Now I'm not about to go through all of these tabs we see at the top here because most of them are identical to what we just saw in our forward lookup zone. The only difference exists on the Wins-R tab. Now on this tab we can specify a Wins server to provide further resolution for reverse queries which are not found in the zone. But Wins isn't indexed by IP addresses, so the DNS service cannot send a reverse name lookup to Wins to get the name of a computer by sending it an IP address. Now because Wins lacks a reverse lookup capability, when DNS receives a reverse lookup request on an IP address, DNS directly sends the IP address in the reverse lookup a node adapter status request. The node status response is received back, and let's say it just happens to be a computer called Bob's PC. The DNS server would then add testdomain.com to the end of Bob's PC, or whatever name that we happen to enter here in our domain box, and it will forward the response back to the requesting client. Now as with the Wins tab we looked at on a forward zone, if you do have non-Windows 2000 or 2003 DNS servers such as Bind, check this box to not replicate this record. Otherwise you might fall victim to the zone transfer problems we mentioned when we discussed the forward lookups earlier. Now the advanced button is exactly the same as before, just allowing us to cache IP addresses that it resolves, and it will keep them by default for 15 minutes. And we also have the same Wins server lookup of 2 seconds before we'll receive an error message. Okay, in this video we've looked in detail at the properties of our DNS server and the forward and reverse zones. We've discussed the advanced configuration and using logging to troubleshoot DNS. Administering DNS is a very important task, as DNS is the foundation on which Active Directory and so many other applications are built. So make sure you understand DNS and how administering your DNS server can maximize the performance and reliability of your network.